Hi, I'm Singh. Welcome to the Value Creation Mindset, the podcast that explores the principles behind the decisions successful business leaders make to create value for themselves and their customers. Today, I am joined by Rajeev Kulkarni, the Chief Strategy Officer at Extra 3D and a longtime operator in the 3D printing industry who has spent decades building and scaling businesses at the forefront of advanced manufacturing. In this episode, we'll unpack how value is created in advanced manufacturing, how Rajiv thinks about scaling hardware enabled businesses, and why relationships, distribution, and trust are becoming more important than the tech itself. Rajiv, thanks for joining us.
Thank you. Thank you for having me. It's a pleasure to be here.
Thanks. For listeners who may not know you yet, what's the problem space you are most focused on right now, and why does it matter to you and your customers?
Yeah, it's a great question actually. My main area it remains 3D printing and additive manufacturing. We started this industry 35 years ago, and the focus was at that point just form, fit, and function verification. Create parts that people can see, touch, feel to make sure their designs were correct and acceptable. But over time, we realized that as complementary technologies evolved, that 3D printing can truly change lives in a way that it creates parts, objects, devices that can truly touch and feel the human life. Not only that, we also realize that 3D printing can move forward as a production solution and make parts for end use applications, which was not the goal initially, but it evolved over time. And just to bridge the gap between where we were about 20, 25 years ago as a prototyping solution to where we would like to be as a production solution is really what excites me about this. And in that sort of realm, just getting into a diversity of applications and solutions that we can really target is what really keeps me busy and is the space that I'm really engaged in at this point.
Yeah, you're in a very diverse space. Manufacturing fundamentally is a very deep and broad area. I know coming out of college, I got my first job as a manufacturing engineer and learned what it took out on the shop floor. But yeah, I was thinking about this. 3D printing is a horizontal technology. There are so many applications and so many spaces. And I also know from personal experience how challenging it can be to sell and promote and drive any kind of horizontal solution. So I know in the past you had mentioned, or on an earlier call, you had mentioned that traditionally 3D printing positioned itself against traditional manufacturing. And you had mentioned that was the wrong move and that kind of held you back. So the two part question, now that you and the industry seem to be shifting to a supportive role for traditional manufacturing, how much movement has that created in terms of uptake, in terms of adoption, in terms of scale? And secondly, have you have you found that verticalizing your efforts has been helpful to penetrate? Or have you mostly been focused on improving the overall horizontal solutions?
Yes, it's the core fundamental issue of 3D printing, in my view, is manufacturing in itself is in trillions of dollars worldwide. And if you look at the 3D printing industry, it's a $25 billion industry at this point. So I would say that we've not made even a dent on manufacturing, even through the 30, 35 years that we've been at it. And I think initially, as we positioned ourselves as an alternative to traditional manufacturing, perhaps it was a bold step to take forward in terms of getting attention towards what we were doing. But I think in the long run, it's another tool in a toolbox, in a manufacturer's toolbox. It is not something that is going to replace all of manufacturing. In fact, there are specific areas and niches, application solutions, you may call it, where 3D printing does really well. And those are the only areas where it should be used. If you start off with the manufacturing process, rather than starting off with the end outcome that is required out of the manufacturing process, then you typically did not end up where you want to end up. And that's been the challenge of 3D printing is the technology is so cool and customers, OEMs get so enamored with the speeds and feeds of the technology that the focus, which is truly the value of the end part that you want to get, loses its attention that is required. And I think that's been the challenge. I think today, if you look at 3D printing, there are 5 or 6 technical value propositions, right? It's either you eliminate the number of parts in an assembly, you reduce weight, you increase operational efficiency, you can use multi-material parts. And on the business side, you get distributed manufacturing, you get operational efficiencies, you streamline the supply chain. If you look at all this value that this technology brings in, and if you look at the application or the solution where you would like to apply this, if none of these apply, do not use 3D printing, I would say. Stick to traditional manufacturing, which is really good at doing what it's doing today. But if any of these value propositions truly add value to the end result and the end outcome, then you should truly explore 3D printing as a customer and apply that. And I think we miss this initially in the initial phase of 3D printing. We understand this as an industry now, I feel, and a lot of customers and OEMs are shifting in that direction. So I think it's going to change over time, I think.
So really, the main resistance has been inertia. Either that or trying to force fit something where there's not a natural fit. If you put the cart before the horse, and we've seen this in multiple industries. There was a new technology. It seems very exciting. Everyone on the board is asking questions about it. Hey, why aren't we doing this? Why don't we do this? We should do this. There's a push to latch on to something. And sometimes the engineers who may or may not be listened to based on the culture of the organization, they're the ones asking, how do I fit this? How can I use this to really create value? What are the other alternatives? And at the end of the day, the whole point of manufacturing is to produce higher quality products and efficiently, right? For less time, for less money. It's really as simple as that. And I think if you put the cart before the horse, either say, all right, you must use 3D printing in manufacturing. It's you must use AI in your day-to-day work, and I'm going to hold a gun to your head and make you do it because there is supposed to be value creation out of it. It's the motivation, the intention is always about efficiency and time savings and cost savings and competitive advantage, regardless of what that shiny new tech is. But sometimes you've got the crusty older engineer asking very troubling questions. This isn't really going to drive an improvement, right? It might look good, but when you tear it all down, is it moving the needle? So the challenges are very similar in the physical domain with manufacturing and certainly in the software space that I've been very familiar with. But what have you found are good ways to break through that and to shift the conversation away from the shiny bits and down to actual value creation, and which will impact, ultimately, that's what people want.
The simplest way to position this conversation with anybody is forget 3D printing for a moment. Just take 2 traditional technologies, take a foundry process and take machining. Now, if you go and say to somebody that, okay, if machining is the process that's being used today to make something, and you say, you shouldn't be using machining, you should be using foundry processes, they will fight tooth and nail. It's the wrong process. It's not the right thing to do. This is a different type of part. We need properties that are very different, whatnot, right? Now you bring in 3D printing, which is just another process, just like those two. And it should be analyzed the same exact way, which is, why do I need to use 3D printing for it? If none of the five technical value propositions and none of the five business value propositions apply, then don't use 3D printing. And you need to start with the question, which is, why should I use 3D printing, really? Rather than, and if you prove to yourself there is a value, perhaps, let's take an example, right? Invisalign is a good example that people use all the time, is that whole business model was based just on 3D printing custom aligners every day in and out. So nothing else could truly actually be used. You couldn't use a CNC, you couldn't use foundry processes economically and in a way where value could be created on the economic side as well as the technical side. So it's a great example on why it was successful, because there was a complete fundamental reason why 3D printing had to be used. Same goes with hearing aids, right? Most of the custom hearing aids in the world are 3D printed. Why? Because you can do 90 in an hour versus somebody having to carve each hearing aid in 90 minutes. And now you see economic value there. So you really have to start with the value and then go out and see which technology applies. Whether it's 3D printing, whether it's foundry processes, whether it's milling, CNC, whatever it is. And if you start that way from the core value that you're seeking, and then you go out to the technology, I think that's a good way to challenge the status quo and challenge the engineers who are ingrained into what they're doing today in terms of traditional processes, I think.
That makes a ton of sense. I hear a couple of lessons here. One, always remember Godzilla. The answer is let them fight.
Yes.
You want the foundry engineer and the machining engineer to argue and to have loud conversations and figure out ultimately in this particular context what is the right mix. And the 3D printer engineer is just in the mix. Let them fight it out. You want that kind of passion. And ultimately the target should be relatively clear, right? The actual
Correct.
final so you start with the end in mind, and the rest is let it filter through that engineering process that will yield the best balance of various things, because that's what good engineers have to do, right? You have to
And
balance.
that is still a technology focus, right? Because then there is supply chain enablement. You have to change workflows and design and everything that happens before and after printing. You have to make sure that the company has enough risk aversion that they are willing to take this step. So all those factors come in as a second layer, I feel. The first layer is to understand what sort of part or object do you want, and does 3D printing make sense for that?
It's very interesting that you point this out, because you're right. If we let engineers design and build everything, yeah, we would get what the car that Homer Simpson designed, right?
Sorry, it is the
So you have to pass this through the economic filter, all of the business constraints, everything else. So the that makes a ton of sense. And you put something in kind of stark contrast for me. You said you have to look at the technical value and you have to look at the business value.
right.
Business value is pretty easy to measure. By our definition, we measure value creation at the business level in four ways: revenue retention, that new revenue generation, lifetime total value, and cost reduction. That's it from that side. Help me understand how in your space you would measure the technical value. What are the KPIs you would look at that
Yes.
would
So the most important one that has been used is part cost. Is you have to look at the entire process. So you could easily say that I can print 10 parts in 10 minutes using a 3D printer versus having to manufacture a part. But truly, you have to first design a part, you have to pre-process the part, you have to identify the material, you have to print it, you have to post-process it, you have to finish it, and then you have to put it into end use. That entire cycle defines the part cost of what is being produced. And unless that part cost is better than what you're doing today, there's no reason really to do this, unless you have operational efficiencies that come into play, or perhaps you reduce the number of count and number of assemblies that have to be done after you print. You can reduce part counts. So there are many technical metrics like these that can be used. Not all apply in every case, but there are some that apply. And if you find a case where everything applies, then you really hit a home run at that point, I would say. So let's take an example, right? Rocket engines. Rocket engines is a great example. Hundreds and hundreds of parts go into making a rocket engine. And now technology has reached a point where generative AI can actually design an engine and they can print it in one shot as one piece. Now you've reduced all the assembly, the failure points, the failure modes. If you reduce the weight, you've done some formal cooling and you've increased the operational life of that engine. What that has done is truly enabled all the different value propositions that 3D printing brings to
And
the
you've
table.
improved reliability.
Yeah,
Fundamentally,
absolutely.
right?
Fundamentally. Look at what SpaceX is doing. Look at what it's just so
I know.
it's there's so much 3D printing and all of that. And Divergent Technologies is another example, right? They designed this car which truly uses generative AI to design the entire chassis of the car and many other components that fit on it. They just don't use any standard processes to do this. It is completely AI and it's completely 3D printed. Again, it's a high-end car, but they've proven that there is an engine that today they're applying to a car, but tomorrow they can apply to another sort of area and a vertical and application, and it can go forward with the generative AI and 3D manufacturing that enables all these operational efficiencies, I think.
No, there's almost no end to where 3D printing applies. There are a few companies out there that are trying to 3D print homes, right? With, from what I've seen, relatively limited success. Lots of promise. You get politicians excited about low cost housing. They might do a pilot project. These things don't often go well. In that particular space, is the issue principally materials based? Or what
So,
have you seen? Are you
so
familiar with that space?
yes, so it's changing quite rapidly. You have houses now that are 3D printed. In Austin, actually, there's a facility that a whole community that has been 3D printed. Just 200 houses. All the houses are 3D printed, and now they're expanding it further. Again, labor cost reduction is one value. Second is time to market, I would say, because a house can be 3D printed in a week's time, most likely. You still have to do the traditional windows and the plumbing and the wiring and all that. But the time to market is extremely low. And then the total cost is low. So it works. But today houses are traditionally ranch houses, which are not generally multi-stories. You can't build huge structures. You can build small structures. But that's where you start with any technology, right? You take the low-hanging fruit, you start perfecting the applications, you start improving the technology, and there's no reason why it can't do bigger and better stuff in the future. So I think there's a whole play there. And think about this, right? Refugee homes or war zones or rural areas where it's very tough to take traditional building materials and building technologies. This is a great way to get real durable construction going on in a very quick time span. So there is value there and there's value being created. Perhaps it's not everywhere today just because it has to take the steps to become everywhere and come
And
everywhere.
in that particular space, I imagine there would be some regulatory issues that would be
Yes.
holding things back. And anything
Also,
else?
also like earthquake resistant and you have to get certified. There's insurance, our insurance companies willing to certify and insure these houses and homes. So all these questions come into play now. But I think these are problems that are easily solved as the things get better. I think.
It's only been 30 years, right? You're just getting started.
Yes.
We founded Modularis 26 years ago, and every day still feels like day one. There's still a long way to go on when you're innovating, when you're pioneering a market. The there are You have to make certain choices about where you put your energy.
Mhm.
You're always trying to draw some kind of contrast with the status quo, right? Because that's where the inertia is. You have to overcome it. And in your space specifically, you had brought this up. There's a incremental approach. Here's an alternative to a traditional process which can bring incremental gains. And if they're significant enough, people are going to listen, right? But then there are specific applications, specific verticals, say rocket engines. You can't do this traditionally. You need 3D printing in order to accomplish certain results. And I've always found that if you can provide a binary option, a step change function, rather than just, okay, bent the curve a little bit, if you can make a larger difference in a very specific niche, it's a heck of a lot easier to move the needle and get the funding and get interest. So I do you find do you have to do both? Or you focus more on just these step change outcomes or products or specific verticals where 3D is the only real game in town now?
So
Or do you are you trying to also help with the incremental gains?
it starts with a step every time, right? So let me give you an example, perhaps. Which so we started doing jewelry patterns, wax patterns for jewelry casting in 1997, and that time we used to print wax parts, which used to be casted in gold and silver to make jewelry. And even today, less than 10% of the jewelry customers use that process, but it's been 35 years, right? Earring eggs. We started again in 1995. Widex was the first customer to do it. And in about 5 years, we went from all art to all digital. This was early 2000s, actually. Like people had not even heard about 3D printing. Invisalign started in 96. Knee joints, hip joints. I can give you examples after examples where it has taken us 20, 30 years to really churn out a vertical or an application. And yet penetration is 10, 50, 20% at best. 80% of that vertical is still doing traditional methods and traditional processes. Everything that goes in your mouth, the bridges, crowns, dentures, veneers, surgical guides that orthodontists use, everything can be 3D printed, is 3D printed, and is used. But yet the penetration of 3D printing today in dental is less than 20%. So the thing is, even with step changes, status quo has such a powerful inertia that it takes a long time. Sometimes the generations have to change until it truly gets adopted. And so it's as much as a technical problem, as much as it's a cultural problem, because I wouldn't even say it's a problem. It's just the process that you have to go through. I'll take another thing. We've seen the hype cycles all the time, and the hype cycles go through their ups and downs and so forth. The most interesting thing I've ever looked at in a hype cycle is if you map an hype cycle with when different types of demographics who actually use the technology come into play, you will see that hype cycles have different personas that come in different portion of the cycle. And which is why even if you know the ups and downs of a hype cycle, and even if you plan ahead, you're still going to go through that cycle because the customers you cater to at different stages of that hype cycle have completely different characteristics and personas. And you cannot avoid that because the early adopters have to come initially, and then your mainstream comes later, and then your live versions of it come. But that's exactly why you go through the hype cycle. It's the same exact thing is you take 3D printing and you insert it into any application or vertical. Each of that vertical is going to go through that hype cycle. It's not just the entire of 3D printing going through that cycle, but each vertical sort of moves through that cycle. And to harness the value that you are going to generate by using 3D printing in that specific application at the end of the cycle, you truly have to go through those steps. It's very difficult not to go through that step.
Just
Yes.
steps are unavoidable. It's a law of the universe.
So rather than thinking of this as a step change or an incremental change, if you map your funding and your investments to the personas that are coming in at the different stages and the stage of the hype cycle that you're in, don't invest everything you have in the beginning of the hype cycle to just develop the technology, because My experience tells me that you need $4 to $5 per R&D dollar that you've invested to really get adoption of what you tell. So if you spend $1 on R&D, you have to spend $4 to $5 on marketing and go to market later on. So if you use all your funding initially in the initial part of the cycle, you will not left with anything when you actually need to facilitate adoption at a later stage. So my take would be,
So early stage R&D should be 15-20% of your total spend.
yes,
Period.
if you look at the total investment, to get everything penetrated and adoption happening in a way that the business is successful, that is, in my view.
Now that's for early stage. What about after product launch, say after the 5-year mark?
Then, so if your sales cycles are shortening, if you are getting repeat sales, and if your ARR is increasing, then you need less and less investment going forward, I think. But if those three metrics are not changing for the better, then you still have issues, or you don't have a good product market fit, and adoption is still perhaps exploratory rather than really changing the business model for the customer, I think.
You said,
The one point I'll make is,
yeah,
we always think about 3D printing going in as a technology and replacing an existing technology. In fact, it's completely the opposite in my view. You are actually going into a customer application and changing the entire business model of that application. And if you cannot change that business model for the customer for the better, I would say 3D printing is not the technology that should be used in that at all. Because it has to truly create economic value by changing the business model. Otherwise, it's just a good to have or a distraction for them
yeah,
rather than, yeah,
be lost in the noise.
yes,
So if you're pioneering new value creating technology, and even if you've solved the particular application challenges, you've articulated the overall value creation potential. You're saying that if you can't convince a prospect to take a fresh look at their business model and to reimagine it, it's too easy to brush it off.
correct.
So
Yep.
which really is the best explanation for why penetration and market share takes decades?
Yeah, yes,
Because people are not willing to look at their business model very often or very easily, right?
yes. And I would say we look at KPIs, we look at metrics, and we tend to focus on internal KPIs and internal metrics. And in fact, it should be exactly opposite. All KPIs and metrics should be related to the customer, not for your
Absolutely.
own, not for your own business, really.
100%.
So
100%. Yeah, no, I'm turning into a broken record with everyone on my team because I tell them every chance that I can. Look, every waking moment, I'm asking myself, how can we create more value for our customers?
exactly
Every
right.
waking moment. And I heard a terrific story once that there's a family was at a important event, and the father, who was a business owner, his phone rang with maximum volume with the most annoying ringtone. Everyone's very annoyed with him. And his explanation was that ringtone and that volume level is reserved for when customers call. It doesn't matter if I'm in the middle of a family event. I'm sorry, the customers come first. And no, that's not particularly good marital advice or anything else. But
Right.
if you don't put the customers first and forefront and understand how you can create and deliver value all the way through to the end customer, that means knowing your customer isn't good enough. You have to know your
Right.
customer's customer and all the way down the chain. I'm totally with you on this. You know what? I wanted to ask you there are some things that can speed adoption. And in your space, I've been following Russia's war against Ukraine very closely. Ukrainians have shown immense commitment and guts. After all, they are fighting for their existence. And they're certainly proven to be extraordinary engineers and innovators. And now they've applied 3D manufacturing at the point of need in order to manufacture drone interceptors to take out Shahed drones and other drones. And they've accelerated the innovation on the drone side just since what, in the last 4 years, to a tremendous degree. And but I suppose if you are fighting for your very existence, that's a good motivator to innovate faster and to adopt whatever technologies that might be needed. What are your thoughts on the use of 3D printing tech in the defense space? It seems mandatory at this point, does it not?
So I think there are two thoughts here. One is governments in the world, just not US, I would say, are for the first time thinking as manufacturing capacity and manufacturing capability, both as core competencies of the country. And that is changing because that's a significant change from where we were 10 years ago or 15 years ago. Today, each country is putting walls and guarding their walls to make sure that manufacturing remains inside the country and becomes a core competency for the country. And that's for two reasons, in my view. One is it creates jobs and it protects jobs for the population. And second is it lets you react faster without the dependency on perhaps other countries. I think both go hand in hand. When you say Ukraine uses drones or somebody else uses some other technologies, I think it's completely feasible. I think if you look at where 3D printing is succeeding in 2025 and 2026, defense happens to be one of the biggest segments where the growth is growing rapidly, partly because they can do at-point manufacturing, they can do distributed manufacturing, they don't have to rely on parts that perhaps have to be shipped from long distances, and they can iterate faster on new things that they want to try out. And all those things are helping things move faster within the defense segment. On top of it, it's other than healthcare, I feel defense has the biggest budgets to support manufacturing. And that helps as well for the industry. So I think, like you said in your last sentence, is it's almost a necessity that happens. We've seen defense and governments create technologies that then filtrate into the consumer level at some point and really change social life and our video life for the everyday person, I think. And so I think this is going to help. While it's perhaps helping certain initiatives for certain countries at this point, I think it's going to help the overall population in filtering new technology that can help not just at the defense level, but at the consumer level as well, I think.
I think you're exactly right. It's become as necessary and visible as it is. Right now, every country on earth is looking at their supply chains, as you said,
Correct.
and is wants to maintain their own manufacturing capacity in certain critical industries. This first started during COVID, right? Whereas, okay, we can't manufacture our own PPE.
Right.
That's a strategic issue. Now, in defense is inherently strategic. It is definitely shaping expectation that we can manufacture things ourselves. There is a lack of dependency on componentry. Now, there are some things that are very difficult to displace, such as advanced chips. There's there's only a few foundries on Earth that can generate a few things, but certainly this is front of mind for a lot of countries, a lot of politicians, and also now consumers. Let me ask you, what do you predict in the next 30 years? Or can you even see that? Can you even see that far? The
Well,
for 3D printing for areas you are passionate about, where do you think the next innovations are going to come from and land?
yeah. So we've been at the Industrial Revolution for 200 years. And I think humanity has reached a point where we can make great objects and we can make great things Yes, we can improve the accuracies and the properties and so forth, but that's fine. That's just incremental changes, right? I feel the biggest change that's happening today in 3D printing is regenerative medicine, in my view. And this is where, yeah, this is where you can print organs using tissue that can go back in a human body. So think about the work that is being done where you, in the simplest sense, you CT scan, MRI your organ, you get the shape of your organ, you capture your tissue, you clean your tissue, you infuse it with cells of that define the signature of the organ, you print the organ, and it goes back into your body. And it's your own tissue going back into your body, and you no longer need donated organs. So it might be lung, liver, kidneys, which I think are the first three in the line. And I think 30 years, this is definitely going to happen.
Oh my
There's no
goodness.
question about it. So my feeling is, this is just one example.
Yeah.
I feel this whole regenerative medicine initiative, I think, will help not just fix human bodies, it's going to help improve human bodies, in my view. Because we can keep improving objects like plastics and tables and chairs and
Sure.
metal parts and all day long, but we just to improve the human body and make it more capable, and it can withstand more pressure, it can withstand more temperature, it can do many things that it cannot do today. I feel it's very exciting. It
Mm,
can solve. And I started this conversation by saying 3D printing has the capability to change lives.
yes.
And I wasn't just being facetious about it. All I was saying is, we've done hearing aids, we've done aligners, we've done knee joints and hip joints, we've done surgical aids, we've aided in so many heart and conjoint twin separation, you name it, right? And now with regenerative medicine, if this technology can get us to a point, get humanity to a point where you can have 3D printed organs, for example, that can go back in your body and change the way surgeries are done and human lives are saved, I think it's a huge achievement for the technology. And I think, knowing some of the things that we used to do through 3D systems and other companies, it's very much a reality that's going to happen. It's not something that is way out there. It's just an idea. No, it's at a stage where things are really happening at a point where this might happen in the next 10, 12, 15 years in our lifetimes.
I've read about 3D printed, I think bladders were one of the first organs tried.
I think
And
lungs have been the number one. Yeah.
wait, have any
Well,
of the 3D printed organs been successfully transplanted? Is there
no,
data around this?
not in humans as yet,
Not yet.
but they've been tested at a level where we know they will work in human trials very soon. They will start, in my view, human trials somewhere between 5 to 10 years at the most.
That would be amazing.
Yes,
I Are you personally involved with any companies in that particular space?
I used to be close to the projects when I was working at 3D Systems. Not anymore. Yes, ever
But
since I
following them close. You're following
Yes, yes,
Facebook
yes,
very
absolutely. I have many friends. I have many companies I know of that are working in the space. These are people I worked for decades with, and they're doing great work in this area. Personally, I'm not doing any work at this point after I've left 3D Systems.
I get you. Sounds to me like that's the work in that space is aligned with what you want your legacy to be.
I think it's a legacy for this industry, this 3D printing, additive manufacturing industry. I think if we can make that happen, I think it would be tremendous achievement for the technology and the industry as a whole. And just to be there right from the beginning when we started the industry to reaching a point. Luckily, I was very young when I started. I was 22 years old when I started doing 3D printing. So even after 30 odd years, I'm still very young that I get to see another 30 years hopefully that I have seen this technology truly change the face of humanity in many ways, I think.
Yeah. And
So,
hopefully with advancements in regenerative medicine more than 30 years.
Yeah, that's right. Interesting. I was driving through San Francisco once and I saw this big billboard and it said, the person who's going to live 150 years is already born. And if you really think about it, it is completely true. It is completely true. And I did the whole math. And if you look at AI, 3D printing, DNA decoding, robotics, you look at big data, and if you converge all of this, where is all this heading, right? All these are independent tracks going on their own, but they are eventually converging, all of them. And when they converge, they're going to converge to improve the human body, in my view, because we've already improved all the objects we want to make as much as we can. We need to focus on something else. I think we need to improve the human body. So that's just my thought on it. And if that premise is correct, I truly believe we have a person, kids who are 10 years old, 5 years old today, can live 150.
See, Rajeev, this is
So,
what's wrong with you. You're thinking too small, you know? No, that's amazing. Rajeev, thank you for your time. This has been a terrific conversation. I sense your passion and your commitment. And now you've got at least another 30 years of innovation left in you.
I hope so,
So
yes.
thanks again. Do you have any message you want to leave our audience with?
The only thing I would say, which we didn't talk on, was the impact of AI on 3D printing or just everything that is going on in the space and outside it. And I feel AI will impact a lot of manufacturing for the better, I think. There are goods and bads that come out of any technology. AI is similar to that, where we talk about jobs getting lost and all of that. But I think AI has such tremendous power to improve manufacturing. The biggest concern for all manufacturing processes is always reliability, repeatability, and accuracy and consistency. And I think AI has the first time there is a software solution that truly can create workflows that are truly closed loop and are reactive to the very instant of things being done, to a point that it'll improve all those four metrics for many manufacturing processes, not just 3D printing. And I think the impact of AI in manufacturing is going to be very positive, I feel.
I agree with you. And I would apply that a little more broadly, not just the manufacturing of physical products, but the manufacturing of software products.
Yeah.
As long as it's applied with a clear understanding that the product life cycle can't be violated.
Right.
I think where people get into trouble is they think, oh, I don't need to do discovery anymore. I don't need to do design anymore. Architecture, we'll just let AI handle that. You know, these are fundamental, essential components in the life cycle that are timeless. But if you own that context, it's really a question of how do you leverage AI most effectively to improve and drive excellence in each of those areas. And there's huge potential there.
Right.
Total way to there. So I think it seems to be a little bit of a theme of this conversation. The right path forward is to combine the best of the old school with the most advanced modern technologies that we possibly can, understanding that there are timeless principles that will still be timeless 100 years from now. As long as
Right.
we know that and we're not stuck in the old ways, we aren't captured by the inertia. Oh, we haven't done it this way yet. As long as we're open to that, I think that combination is what will drive humanity forward the fastest.
Well said. Yeah, I agree with you. Yes, absolutely.
And avoid the results of documentaries like Terminator, right?
Yeah, we all know that. Thank you for having me. I really enjoyed the conversation and
Right.
would love to meet you in person someday very soon.
We will make that happen. It's a very
Yes.
small world and it's growing smaller still. All right.
Yep.
Thank you so much. You take care. Thanks for listening to this episode of The Value Creation Mindset. I'm AJ Singh. If this episode helped you, please follow the show, leave a rating, and share it with one person who you think it will benefit. For show notes and more, visit modularis.com/podcast. See you next time.